This is our project presentation for embedded system. I'm Xuedan Zhang.
I'm Hongfei.
I'm Zhonghao.
Here's the outline for our presentation, our goals and introduce and completed work and conclusion in the end. For our goals, we want to make a useful device in our daily life. Thinking about that, we use smartphones, tablets every day. We decided to design an intelligent face-following holder to hold those objects. We can use it in many situations, in the car, in a meeting, in the office. We want to control this holder in 3 ways, and it lists according its difficulty degrees. The first one, control the holder by remote control. The second one, holder by people's sound, and the hardest one is by recognizing people's face.
And the figure on the right shows the main part of the hardware we used in the project. First, I want to introduce is the Mini 2440 development board that we used in our project to build the whole system. It is a low-cost single-board computer based on a Samsung ARM9 microprocessor. We choose it because it can support our project with its numerous function modules and rich peripherals such as USB and integrate LCD controller. And the second is the OV9655 camera board. Its image sensor is a low-voltage CMOS device that provides the full functionality of a single-chip SXGA camera and image processor in a small footprint package. It makes it's possible to take photos or record video with our development board. The reason of using it is that it is suited for Linux kernel drive use, and the board directly provides its interface circuit. And the third is AU. It's a microcontroller board based on a 80 mega microchip. It contains everything needed to support the microcontroller, and we use this board to make a remote control with Bluetooth.
For software, OpenCV is a library of programming functions, mainly aimed at real-time computer vision. And because we have to use OpenCV library to do face recognition, we must use embedded system to do our project. And then we choose Linux as our operating system because Linux has a lot of information of resources. This one is the overview of our project, and we have a funny video here.
This is the section A for our project. In this section, I use the Arduino Uno microcontroller board and Bluetooth module to make the remote control. It has a 2-channel analog to digital convert, which can convert the analog signal collected by the remote control to digital signal. And the digital signal would be given to the Bluetooth module, then to the system wirelessly. The PWM will generate the signal to control the servo. In this section, we mainly use UART in the Mini 2440 development board. We write the code for the user applications to call the device drivers to operate the whole system. This is the remote control we designed. After configuring the system and connecting every part of the hardware, we can control the holder by the remote control correctly for each direction. We spent many time on writing the code for calling the driver of UART on the Mini 2440 development board.
I'm responsible for the voice controller. And in these sections, our system will be controlled by speech recognition. And the figure shows a speech recognition system structure diagram. The speech recognition system is divided into two processes of speech training and speech recognition. In this speech training process, the voice signal inputs from the microphone will be collected and encoded by the UDA digital audio coder to maintain a certain sampling frequency and sampling precision to ensure the quality of sound reductions. And we input four words in this process: up, down, left, right. The voice template of each word is stored in the storage system. When the user input again, the system automatically matches the collected voice signal with each voice template and gives the recognition results. And the meaning 2440 send it. Then, according to the results, the system will send a corresponding signal to turn the holder's directions. This figure shows the basic principle diagram of speech recognition system. The speech signal needs to be pre-processed after application, analog to digital conversion and encoding. The purpose of signal pre-processing is to prepare for the work below. The pre-processing of signal includes the signal pre-emphasis and the signal framing.
For face controller, this figure is show the principle of face recognition, and we didn't work on it, and we just call the function of the OpenCV. And for this figure, showed our job. Firstly, we use camera OV9655 to guide video. Actually, it is a series of pictures with 70 FPS. That means every second we can get 70 pictures as input. Secondly, we just called two functions from OpenCV library and processing and computing every picture. It can recognize just one person's face. Once it recognizes face, it can put a square on your face and output the position of this square's center and length of the side. Moreover, our camera's pixel is 600 by 800, and the center of the screen is 300 by 400. We use this and the position of face to get the arrow of x-axis and the arrow of y-axis. Lastly, we designed a PID controller because our servo needs an relatively fast speed but do not need high accuracy. So we do not use D parameter, just PI controller. And then we input the arrow of x and the arrow of y to the PI controller. After this, we can get output, which is the PWM of servo, so that we can get the angle of left, right, and up, down. So after we finish this project, we noticed that it is harder than we thought at first. We got big problem on translation of Linux and libraries. And we believe our project can get modification and improvements on 3 points. The first one, we can modify the velocity and accuracy of our remote control unit. The second one, we can modify our algorithm of voice recognition, which can recognize more commands. The third one, because if the pose of face is not good, our project cannot get the position of face, so we can modify the algorithm of face recognition, which can be more accuracy. So that's all. Thank you, Professor.
Thank you, Professor.
Thank you, Professor.